and welcome to today's lesson on slope. This is going to cover some of the topics in Standard 5.1 in geometry, and then it's also going to go over some of the questions in Study Island under the topic distance, midpoint, and slope. This is part 2 of 2 videos that cover the topics in those lessons and standards. So we're just looking at slope today, and this is all review from Algebra 1. So if it looks very familiar, that is why. So hopefully you're able to jog what you learned in Algebra 1, and this lesson will go fairly easy for you. So let's go ahead and look at some notes. First, let's look at the definition of slope. So slope is rise over run. It's the rate of change. Might have also remembered as subtract the y's over subtract the x's, but the main definition that we need to worry about in geometry is that rise over run. So remember, you have to rise out of bed before you can go running, so you're going to count the rise before you count the run. So the way you're going to do that is on the line, you're going to find 2 points that cross at the corner of the square on the grid paper. So here they found the green dot and the black dot, and they counted up 2 and to the right 3. So that's a rise of 2 over 3. And then once you've counted the rise over run, you have to look at your line and decide if it's a uphill positive slope or downhill negative slope. This one's uphill, so you don't have to add in a negative sign. If it was downhill, you would. So in this example, we're going to have to find those 2 points that are along this line that are on the grid paper, the corner of the grid paper. So here's one, and then here's another. You could also use this one down here in red too. Any of those 2 will work. The further apart you go, though, the more you're going to have to reduce the fraction. So I always try to get the ones that are closest. So I'm going to go ahead and I'm going to count my rise, 1, 2, and then I'm going to count my run, 1, 2, 3. So my rise over run is 2 over 3. This is a downhill line, so I'm going to add in the negative, and that makes my answer A. Same thing with this line. I'm going to find those 2 points that are at the corner of the grid paper. So there's 1, there's 2. You can also use this one here. It's your pick. And then I'm going to go ahead and count my rise over run. So here I run 1, and then I run 2, 3, 4. I run 4 to get to that second point. So my rise over run is 1 over 4. This is a positive line, so it's going to be a positive slope since it's an uphill line, and that makes my answer C. When we're talking about slope, you're also going to see questions that deal with parallel and perpendicular lines and their slopes. So remember, parallel lines, those are the 2 that are going the same direction. They never are going to cross. They're like railroad tracks. Parallel lines have the same exact slope. So that means that if one is 3, the other one's 3. If the slope of the first line is negative 1/2, the slope of the second line is negative 1/2. They're exactly the same. Now, perpendicular lines, those are the lines that cross at a 90-degree angle. And their slopes are opposite reciprocals. And what that means is the signs are opposite, so you change the sign, and then reciprocal means you flip the fraction. So if 1 is 3 over 2, you're going to flip that to 2 over 3, positive and negative. The first one's 4, that's really 4 over 1, so you flip that fraction, it's 1 over 4, change the sign, it's negative 1 over 4 is the perpendicular slope. So just knowing those 2 rules are really going to help us on these last questions. So here it says line R has a slope of 4. Line S is parallel to line R. What is the slope of line S? Well, my rule for parallel slopes is they're exactly the same. So if the first one's 4, the second one's 4. So that makes my answer C. Just simply knowing that rule makes this question fairly easy to get right. Here it says, what is the slope of a line parallel to line Q? Well, here's line Q. Well, I know that parallel slopes are the same, so if I can find the slope of this line Q, then I can find the slope that's parallel to it also. They've already marked out 2 points that are on the corners of the grid paper, so I'm going to count my rise and my run between those 2 points. So I'm going to rise up 1, 2, and then I'm going to run 1, 2, 3, 4, 5, 6. So my rise over run is 2 over 6. Now I can simplify that fraction. They're both even, so 2 divided by 2 is 1, 6 divided by 2 is 3. And then the last thing you have to remember is this a downhill line or an uphill line? This line is going downhill left to right, so that means it's going to be a negative slope. And I'm looking for the slope parallel to negative 1 over 3. So that means it's going to be exactly the same, and that makes B my answer. This one is similar, but it wants to know what is the slope of a line perpendicular to line P. Well, perpendicular slopes are different signs and the fractions are flipped. So I'm going to go ahead and find the slope of this line P first. And so you can find the slope between S and T if you want to, but I see that those are pretty far apart. So I'm going to pick S and this purple point just because then it's going to be smaller numbers and I won't have to reduce. So I'm going to count my rise, 1, 2, and then I'm going to count my run, 1, 2, 3, and that's going to be my rise is 2 over 3. This is an uphill line, so my slope is going to be positive. So the slope of line P is 2/3. To find the negative, or to find the perpendicular slope, I'm going to flip my fraction. So 3's now on top and 2's on the bottom, and change the sign. So this one's going to be negative, and that's my answer, C. This question reads, line V has a slope of negative 7 over 6. Line W is perpendicular to line V. What is the slope of line W? So here they give me the slope. I don't have to count it out. I want the perpendicular slope, so all I have to remember is I need to flip my fraction. So 6 is now on the top and 7's now on the bottom. And I have to change the sign. So I was given a negative slope, so it's going to be changed to positive. So my slope is now positive 6 over 7, and that's the perpendicular slope, and my answer, letter C. We're going to look at some questions that deal with parallel and perpendicular, but then also horizontal and vertical slopes. So if a line is horizontal, which here is an example of a horizontal line, it's going to have a 0 slope and it crosses the y-axis. So we use the acronym HOI to help us remember that horizontal lines have a 0 slope and cross the y-axis. And vertical lines, which here's an example here, vertical lines and horizontal lines are perpendicular to one another. They're going to have an undefined slope, and they're going to cross the x-axis. So if you think about it, if you're skiing, a horizontal line is 0 fun, so it has a 0 slope, and a vertical line, if you ski that, you're gonna die. You're gonna become undefined. So that's another way you can remember their slopes. So, and we also use, for vertical lines, we also use the acronym VEX. Vertical lines have undefined slope and cross the x-axis. So now we have this line M. It has a slope of 0. So that's a HOI line. That's a horizontal line. And line N is parallel to line M. So their parallel slopes are the same. So what is the slope of line N? Well, knowing that they're exactly the same, if one is 0, the other one's going to be 0. So my answer is A. line P has an undefined slope. So that means it's a vertical line that vux. Line Q is perpendicular to line P. So what is the slope of line P? Well, I'm given a vertical line to begin with. So what's perpendicular to a vertical line? A horizontal line. And the slope of a horizontal line is 0. So my answer is D. So this is just where you have to know that, and this is a special case where you can't just flip the fraction and change the sign. It's going to be undefined and 0 are a pair of perpendicular slopes. And then our last question, what is the slope of a line perpendicular to line R? Well, if I'm looking at this, this is a perfectly horizontal line. So my slope here is 0. So a perfectly vertical line is what's going to be perpendicular to that. And the slope of an vertical line is undefined. So once again, this is another instance where I can't use that rule. It's a special case. So my answer here is going to be A, because 0 and undefined are a pair of perpendicular slopes. So I'm glad that you joined us today, and I hope you learned something new.